trying to sleep, being fair. When there's something to share, being neat. When you're folding a sheet, that's mathematics. When a ball bounces off of a wall, when you cook from a recipe book, when you know how much money you owe, that's math.
Hello everyone, this is Understanding Einstein here. In case you're wondering why this is on a different account, it's on my school account. It's a standalone video. It's actually an assignment for a class. So with that said, I gotta start. I need 10 minutes and I'm gonna just show you guys the theory behind exact differential equations and how to solve them. So first I'm going to start with a little bit of theory. I'm assuming if you're watching this video you have taken Calculus 3. Now we learned in Calculus 3, and I thought this was awesome when I realized it because I love connecting math in different ways, and we learned in Calculus 3 that an exact derivative was some function existed, f of xy, okay, and if you take the derivative of this with respect to x, so you have an f of x, and then you take the derivative with respect to y after that, so you have an f of xy here, then that will be equal to the same thing as if you were to take the derivative of f of y and then take the second derivative with respect to x. So we'll have f of yx. And what that basically said was that f of yx was equal to f of xy. And if this was true, then it was an exact derivative. So what we're doing is we're going to work backwards. And what you end up doing is you end up starting out with the first derivative with respect to y and the first derivative with respect to x, of course from the same function. Now we don't know this, but we assume this. So what we do is we take this one here, and first we have to check and make sure that this is true. So we will take the derivative with respect to x, so that will be f of yx. And then this one here, we'll take the derivative with respect to y. And this will be f of xy. And if they are equal, then it is an exact differential equation. Okay? Now if it is exact, and this was only checking it, this was the part where you check and see if it was. If it was exact, then you have to go back and you have to integrate both of these guys here. I'm going to throw a little integral sign on them with respect to their value that was already, we assume that was the derivative, and you'll get two parts to your final function, and your final function will be f of xy, a full function. So here's the problem. It says determine if the given differential equation is exact. If it is exact, solve it. This is our differential equation. 2x minus 1 with respect to x, or times the change in x, plus 3y plus 7 times the change in y is equal to 0. So what's the first step? So the first step is to identify the parts of the equation. Now, the part of the equation that is attached to dx, your book will call m, or m of xy. It's a completely separate function we're treating it as. And the part of your function that is your equation that is connected to dy, they will call n, or n of x. So let me write that down. We have an m of xy and we have an n of xy. Now I never really understood why they do this. I think it's confusing. So what I'm going to do is I'm going to go back to Calculus 3 and I'm going to call these for what they are. I'm going to call this f of some function of xy with the derivative of x. Okay, the partial derivative with respect to x. And I'm going to call this function the same function but with the derivative of y. This is what we are assuming. We are assuming that these two parts of the equation are partial derivatives of a higher equation. Okay? So now what do we have to do? Well, we know that f of xy should equal f of yx, so what we end up doing is we end up taking the derivative of this one with respect to y, and we end up taking the derivative of this one with respect to x, and then we compare them and see if they're equal or not equal. Now if they're not equal, they're not exact, and if they are equal, they are exact. So let's crank through this and see what we get. Alright, so we know that this here, I'm going to start over here. Well, we know that this here is f of x already. And we know that that equals 2x minus 1. What we need is f of xy. So that's your function with the derivative of x and then with the derivative of y. So now we take this with respect to y, and what we end up with is 0. Okay. Same thing over here. We're going to take this function. I'm not going to write it backwards. Is fy already. And we know that that is equal to 3y plus 7. But we don't want that. What we want is f of yx. And if you take the derivative of that with respect to x, you're going to get 0. Now this point, we're done checking this thing. We can see that f of xy is equal to f of yx, and we know that this problem is exact. So now our next step is to unfold this thing and see what the overlaying function is. So now we go back to our main equations, alright, which were these ones here. Okay? Now what we do is we write the equation 2x minus 1, and we know that that is equal to f with respect to x. Well, how do we undo that? We take the integral with respect to x. So what we have to do is take the integral with respect to x, and you get 2x minus 1 dx. Well, we know that 1 is going to go to x, and we know that 2x is going to go to x squared. So the integral of that, or the antiderivative, is x squared minus x. Okay? So now that half's done. And this is really how simple these are. I mean, a lot of people overhype these. So now we look at our second function and we say, okay, it's 3y plus 7. And we know that this function is our original function that we're looking for with respect to y. We've already assumed this and then we've proved it. So how do we undo that? We take the integral with respect to y. Let me get rid of that. Tack an integral sign on here, dy, and now 3y plus 7, which is going to be 3/2 y squared plus 7y. Now both of these are going to have your constants on there, but you really only need to keep one of the constants after you put all these terms together. So I'm going to shrink this down. We have our answers already. I don't know, sometimes my program. Alright. So I'm going to shrink this down. I'll put this one on this side. That way we can still see, and I'll highlight what our answers were for those derivatives. Now we know that both of these were partials of each other, alright? So we only want to put all these together, but we don't want to keep repeating terms. And as you can see in this example, probably a poor example to pick, I have an x squared term, I have a minus x, I have a 3/2 y squared, and I have a 7y. None of these terms are repetitive, so we only want to keep one term. The only term that's repetitive is the plus c, and again, we're only keeping one of them. So our final answer, f of xy, the function, not those derivatives, are equal to x squared minus x plus 3/2, oh, that's a y, 3/2 y squared plus 7y plus c. Alright? And that's what we end up getting. Probably what your math teacher is going to expect is a c equals x squared minus x plus 3/2 y squared plus 7y. Okay, that's a horrible y, but you get the point. Alright, and basically I didn't have to have a negative c here because you can have a negative constant, which would cancel out anyhow. It doesn't really matter. But this would be your final answer, folks. I'm going to do one more example. Okay, in my next example, we still have to do the same thing, determine if the given differential equation is exact. If it is, solve it. And the differential equation we are given is 5x plus 4y times the change in x plus 4x minus 8y cubed times the change in y. Now, the first step is to identify your parts. So, this right here is my m. Alright, and this right here is my n. But remember, those are stupid terms, so let's try not to pass that down to generations. So now I'm going to start with my f of x. I'm just going to find the f of xy, okay? Right now we have this portion, we need to take the derivative with respect to y. So 5x is going to drop out, 4y is going to turn into 4, and our derivative is going to equal 4. Now we're going to come over here, and we're going to take, we already have this part, we need the next derivative with respect to x. The 8y cubed is going to drop out, and we're going to be left with, the 4x is going to be left with 4. So we can see that these two are equal to each other. You can draw a huge equal sign in between here. And that means that it's exact. And because it's exact, we can continue with the rest of our problem. So, now what's the next step? Well, we've determined that these are both parts of one equation. And we know that this one is fx, or our function with respect to x. We know that this one is our function with respect to y. So now we need to undo that and to get our final solution. So what I'm going to do is you just take the integral of both. Right? You're going to get 5/2 x squared plus 4xy. And then over here, the integral of 4x minus 8y cubed with respect to y is going to yield 4xy minus, then 8y cubed. You gotta imagine that it's supposed to be a 4 up here. If you put a 4 up here, there's still going to be a 2 left behind. So what you need is 2y to the 4th. Okay? I hope everyone can see that, how if you bring the 4 down, you're going to get an 8, and then if you subtract 1, you'll get a 3. So I've moved our answers up there, and remember that these both have a plus c on the end of it. This one does too, alright? But because we only keep one answer, here's a better example than the last one, because we have two 4xy's. Well, we only want to keep one of those, so our final answer is going to be c is equal to 5/2 x squared plus 4x y minus 2y to the fourth. And there you have it. It's as simple as that. This is Joe Rabideau doing this tutorial. I hope you liked it. Rate, comment, subscribe. And if you have any suggestions or constructive criticism, then by all means, shoot me a message. Thanks.